Happy Thursday, 5M. Go ahead and pause now and check out the link below. It's an area and perimeter wrap. When you're done with that, you can come back to the video. Alright, 5M, let's start out with a warm-up. Find the area and perimeter for these figures. Please pause now and do that. Alright, you're back and ready to see your answers. Here are your answers for those. If you had any questions, please raise your hand. Someone will come around and help you. Today we're going to be finding the area of triangles and parallelograms. Our learning target is I can use formulas to find the area of triangles and parallelograms. First, how would you define base? Base can be any side of the figure, but is usually the side that the figure sits on. So as we did in our warm-up, we saw the base was the bottom part, or what our figure sits on. Our base of our triangle is right there that I just highlighted, and the base of our rectangle is right there. How do we define height? The height of a figure is the shortest distance between the base and the vertex opposite of that base. So in this example, we can see that this is the base, which we found out earlier is what our figure sits on. And it says it's the shortest distance between the base and the vertex opposite of that base. So the base and the vertex opposite would make the height. So we see in this one, found our base, and the vertex opposite of that base, it's right there. The shortest distance between the base and the vertex is opposite that base. So with these figures, it'd be here's the base and the shortest vertex base to the shortest vertex opposite. And this one, here's our base and the shortest vertex opposite. And then this one's a little trickier, but we think of it as this is our base because our base can really be anywhere. This is our base, and the shortest vertex opposite would be right there. So how do we find the area of a triangle? The area of a triangle, the formula, is 1/2 base times height. We learned yesterday that the area of a rectangle was base times height. Now if you're wondering why we use half for a triangle, it is because a triangle is actually half of a quadrilateral. As we can see here, if we put two triangles together, it makes a square. We take this one away, and we see that we're working with just this. So it's 1/2 base times height. We've had a lot of practice with fractions lately, so this should be pretty simple for us if we just make our base and our height into fractions. So we have 1/2 times the base, which is 5. So we have our base, and then we have our height, which is the opposite vertex, and it's the shortest distance to the opposite vertex, which is also 5. So we'll come up here and we'll write 5 as our base, so times our base, which is 5. Now we know with our practice with our fractions that we place 5 over 1 because it's a whole number, place our whole numbers over 1, times our height, which is also 5. So we write that as 5 over 1. 1 times 5 is 5, times 5 is 25. And 2 times 1 is 2, times 1 still stays is 2. Now we can make this 25 halves into a prettier number because we know that this line right here means to divide. So we can take 25, we divide that by 2. Take 25, we divide that by 2. We know 2 goes into 2 one time, and 1 times 2 is 2. We subtract, that gives us 0, and we bring down our 5. And 2 will go into 5 2 times. And 2 times 2 we know is 4. 5 minus 4 is 1, with a remainder of 1. And we know from working with our fractions that the remainder is always the numerator of our fraction, and the denominator is always, always, always the number that we divided by. So that would be 2. So the area of this triangle, 5, with a base of 5 and a height of 5, is 12.5 centimeters squared. Just like yesterday when we're working with area, we always square. Now let's turn to page 313 in your math journal, or you guys can just stay on this page and work and screenshot this. We're going to identify the base and height of each figure, then find the area. So I've left up our formula of area of a triangle, which is 1/2 times base times height. So we'll do this example D together. So we know that our base is what our figure sits on. So it's going to be this area because it's sitting on this part right here. And we know that our height is from the base to the shortest distance to the opposite vertex. So our height would just go up to this vertex right here. And now that we've figured that out, we can go and we can count our squares to see how long this shape will actually be. So we can count our base. 1, 2, 3, 4, 5, 6. We still have a little here. I would say that would be 1/2. So our base is 6 1/2. And now we have to do our height, so we're going to go up. So we go up 1 square, 2, and I would say that our very tip top of our triangle is at 1/2. So that would give our height 2 1/2. Now our formula is 1/2 times base times height. So we can take 1/2. We need to find the times. So we times it, and then we find our base. We see that our base is 6 1/2, but we know we can't multiply a mixed number, so we need to make it into an improper fraction. Remember from working with fractions, we take 6 times 2, and then we take 2 times 6, and then we add our 1. So 2 times 6 is 12, plus 1 is 13. So it would be 13 over 2 as our base. And now our last step is to times the height. So we're going to multiply. And we come back to our figure, we see that our height is 2 1/2. So we need to make this into an improper fraction. And to do that, we take 2 times 2, and then we add our 1. So 2 times 2 is 4, plus 1 is 5. 5 over 2, because our denominator is 2, and the denominator always stays the same. Now when we're multiplying fractions, we just multiply straight across. 1 times 13 is 13, times 5 is 65. Make our over sign. 2 times 2 is 4, times 2 is 8. Like we did in our previous example, we know that we can make this 65/8 into a prettier number by taking 65 and dividing that by 8. 8 does not go into 6, but we do know that 8 goes into 65 8 times. 8 times 8 fell on the floor, picked it up, it was 64. (65 minus 64 is 1. And as our previous example, we know that our remainder is always our numerator. So we'll bring up our 1. And we know that our denominator is always the number we divided by, which was 8. So our answer for part D is 8 1/2. I want you guys to do B independently. Go ahead and raise your hand when you found the area for this and tell a teacher, and then you can come back to the video. Please do that now. Okay, you're back and ready to move on. Now we're going to find the area of parallelograms. Area of a parallelogram, the formula for that is base times height. So with this figure, we need to find the base, which is what the figure sits on, which would be 3. We need to find our height, and we know that we go from our base, and we go up to the shortest distance to the nearest opposite vertex, which would just bring us up right here. And our height, we have it labeled as 6 inches. We just need to label it. So all we do is just multiply. 6 times 3 is 18. And our units are inches. So since we did area, we're going to label it inches squared. Okay, as we found out earlier, the formula for area of a parallelogram is base times height. Let's do this first example here together. So we need to find our base, which is what our figure sits on. It should be right here. And then our height, they actually have labeled for us, but we know that height is from the base up to the, the height starts at the base to the nearest opposite vertex, so just go up right here. And now we need to figure out how many squares there are in our base and our height. So we know there's 1, 2, 3, 4, 5 as our base, so you can write that as 5. Now we need to find our height, so we see it goes up 1, 2, 3. So we can put in our 3. Now what we do is just multiply our base, which is 5, times our height, which is 3. We know that 5 times 3 is 15. So our answer would be 15. We don't put squared because we don't have a unit. I want you guys to go ahead and try this next example independently, and go ahead and raise your hand and tell a teacher the answer once you figure it out. When you're done doing that, please come back to the video. Your assignment for today is to complete worksheet page 269 on the back of your open schedule, and then do math boxes 9.6. Make sure you ask questions if you find yourself confused.